I'm Mrs. Madhura, Assistant Professor, Department of Information Technology. Delighted to welcome you all to the fifth day of the Virtual Faculty Development Program on Cyber-Physical Systems organized by the Department of Information Technology, Dr. M.G.R. Educational and Research Institute. We hope that past 4 days have been insightful and we are excited to dive deeper into today's theme, Research Trends, Tools for CPS. I now invite Dr. N. Kanya, Head of the Department of Information Technology, to deliver the welcome address.
Hello.
Ma'am, your voice is not coming in.
Hello.
Sorry, sir. Respected dignitaries, esteemed faculty members, and dear participants, it's a great pleasure to welcome you all to the inauguration of final day of our faculty development program on cyber physical system, organized by Department of Information Technology in association with Center of Excellence in Cyber Physical System of Dr. M.G.R. Educational Research Institute University. First and foremost, my heartfelt gratitude to our Founder Chancellor, Dr. A.C. Sharmoon sir, and our President Engineer A.C.S. Anil Kumar sir for their continuous guidance and support. We are honored to have our Rector, Dr. D. Viswanathan sir, Rector of your university. Sir, welcome you, sir.
Thank you.
Sir will deliver the inaugural address, and sir's vast knowledge and experience will surely provide us the valuable insights. I'm happy to welcome Dr. Kakelli Anil Kumar sir. He's a professor in School of Computer Science and Engineering, BIT Vellore. Welcome you, sir. Sir is going to deliver his session, talk on research trends and tools for cyber physical systems. Welcome you, sir. I would like to extend my heartfelt welcome to all the participants of this event. You have been a great participant throughout these 4 days. The number of questions, number of responses, and the sessions are much fruitful because of you and your interaction. Thank you very much. I request you to kindly show the same similar interest in the upcoming events also. My heartfelt thanks to the coordinators, Professor A. Kameshwaran and Professor Santarlakshmi for their continuous support and making this event fruitful. And I congratulate the team IT for making this kind of events as a great success. Once again, welcome you all to this event. Stay tuned to learn. Thank you.
Thank you, ma'am. We are greatly honored to have with us today Professor Dr. Viswanathan, Rector, R&D, Dr. M.G.R. Education and Research Institute to grace this occasion. I now invite Professor Dr. Viswanathan sir to deliver the felicitation address.
Thank you, ma'am. Good morning to all. I joined the IT department, HOD and faculty in welcoming Dr. Kakelli Anil Kumar for this program. And I thank Dr. Anil Kumar for accepting our invitation and delivering this keynote address. I am really honored to be here today to discuss the exciting field of cyber physical systems. I would like to congratulate our HOD and other faculty members for organizing this wonderful event for the past 1 week. I only request our Madam Kanya to circulate all these recorded versions of this 5 days program to all the students, not only IT students, but also the computer science department students, so that they will be definitely benefited. As we continue to witness the convergence of physical and computational systems, CPS has become a crucial area of research and development. CPS are mechanisms controlled and monitored by algorithms, tightly integrated with the internet and its users. In CPS, physical and software components are deeply intertwined, able to operate on different spatial and temporal scales, exhibit multiple and distinct behavioral modalities, and interact with each other in ways that change with context. CPS involves transdisciplinary approaches, merging theory of cybernetics, mechatronics, design, and process science. The process control is often referred to as embedded systems. CPS is also similar to IoT, sharing the same architecture. Nevertheless, CPS presents a higher combination and coordination between physical and computational elements. Some examples of CPS we can say: smart grid, autonomous automobiles systems, industrial control systems, robotic systems, recycling and automatic pilot avionics, etc. Precursors of CPS can be found in areas as diverse as aerospace, automotive, chemical process, civil infrastructure, energy, healthcare, manufacturing, transportation, entertainment, and consumer appliances. So like this, CPS integrates physical and computational components to create complex systems that can sense, actuate, and interact with the physical world. These systems have numerous applications in industries such as healthcare, transportation, energy, and manufacturing. The current research trends in this field, as far as I know, artificial intelligence and machine learning, integrating AI and ML techniques to improve systems performance, adaptability, and resilience. Next, Internet of Things, leveraging IoT technologies to enable seamless communication between physical and cyber components. Third one is cyber security, developing robust security measures to protect CPS from cyber threats. And human-centered design, designing CPS that prioritize human needs, safety, and usability. Some of the tools and technologies used in CPS research include simulation and modeling tools, like utilizing tools like Simulink, Modelica, and Ptolemy to design and test species. Programming languages like Python, C++, and Java to develop CPS applications. Sensor and actuator technologies, they are leveraging sensors and actuators to enable CPS to interact with the physical world. As researchers, it is essential to address the challenges and opportunities in CPS, such as ensuring system reliability, security, and scalability. I would like to encourage the researchers and students in the audience to explore the vast potential of CPS and contribute to the advancement of this field. With this, I just conclude my introductory speech, and I thank the organizers for giving me this opportunity. I wish you all the best in your research endeavors. Thank you.
Thank you so much, sir. Let me quickly brief the guidelines for the participants. The FDP is between 10 a.m. to 12 p.m. Feedback link will be shared towards the end of the session here in Zoom. It will be active for 20 minutes. It is the participants' responsibility to stay connected till the end. It will not be shared in the WhatsApp group or by mail. All the participants who have registered for the FDP are not eligible for certification. E-certificates will be provided only for active participants based on attendance taken automatically by Zoom and feedback form submission. We are truly honored to have with us Dr. Anil Kumar, Department of Analytics, School of CSE, VIT, Vellore. To introduce our esteemed resource person for the day, I now invite Mr. Kameshwaran, Assistant Professor, Department of Information Technology.
We are honored to welcome Dr. Kakelli Anil Kumar, Professor in the School of Computer Science and Engineering at Vellore Institute of Technology, Vellore, Tamil Nadu, India. Dr. Anil Kumar holds a PhD in Computer Science and Engineering from Jawaharlal Nehru Technological University, Hyderabad, awarded in 2017, following his postgraduate and undergraduate degrees from the same university in 2009 and 2003, respectively. With an academic career spanning over 2 decades, beginning in 2004, Dr. Anil Kumar has held key academic roles, including Assistant Professor, Associate Professor, and Head of the Department at reputed engineering institutions across the country. His commitment to academic excellence and leadership is widely recognized. His research portfolio is both broad and impactful, covering cutting-edge areas such as Internet of Things, artificial intelligence, machine learning, deep learning, digital forensics, cybersecurity, malware analysis, blockchain, and cryptocurrencies. He has contributed over 50 research publications to peer-reviewed international journals and conferences. Today, we are privileged to gain insights from his vast experience and expertise. Please join me in welcoming Dr. Anil Kumar. Welcome you, sir.
Yeah, thank you very much for the introduction about me. Can you confirm is my voice is clear to you?
Yes, sir. Clear, sir.
Yeah. Thank you, Professor Viswanathan, sir. It's nice to meet you, and it's a pleasure to be with you today. It's really honor to me. And also, I thank all the management of M.G.R. University, Vice Chancellor, and also the Pro Vice Chancellor, head of the departments, and the organizers of especially this program, and also the eminent speakers in the last few days who had delivered various important sessions. I would like to thank everyone, and also for giving this wonderful opportunity to be with you today and to learn along with you in the most prominent field, cyber physical systems. So today I would like to focus on the research trends and also the research tools. As a researcher, where we have to focus in cyber physical systems, and what kind of technologies are available, and what are the research trends. So these aspects I would like to focus on today. Let me allow to share my screen to see our PowerPoint presentation. I hope my screen is visible to you, everyone.
Yes, sir, it's visible.
Yeah. Good morning to all of you, all the participants of this program. I would like to today focus on the research trends and also the tools in cyber physical systems. As my earlier the delegates have already presented about me, I'm Dr. Anil Kumar, working as a professor in School of Computer Science and Engineering, VIT, Vellore. And as an introductory part, I hope you have learned so many things from the last 4 days from the eminent speakers, they have already introduced you what is cyber physical systems and what are the latest technologies and security issues, and also many more emerging trends in CPS. So I hope the last 4 years you have learned many important concepts. So now my focus on in this day is mainly to learn and know what are the research trends, because as it is a faculty development program, so most of you are the faculty members working in various prestigious institutes and universities of India, and also some of the students, I hope, also there as an audience. So it is a good time for all of us to know what are the research trends, so where we can focus to continue our research, to choose this domain. Is it a right platform to do the research or not? And if I choose this domain for my research area, so where I can focus, what are the problem statements, and where I can do a research, and what are the supporting resources are available. So as within the timeline, I would like to cover all these things, so that at last the conclusion of this topic, you will understand that this is one of the most prominent domain, so to take up as your research field. As introductory part, I hope you learned very much about it, as CPS is the integration of the computing systems and networking as well as the physical processes. So these are the three most prominent components of the CPS: the computational power, networking capabilities, as well as the physical processes. And the core components come to the hardware part. If you see, these are the core components which are very much needed for CPS, like embedded systems, sensors and actuators, network connectivity, network protocols, as well as the intelligent software systems. As already Professor Viswanathan sir was highlighted in his keynote speaking, various applications are there from CPS domain, like smart manufacturing industries, healthcare applications, autonomous vehicles, and also industrial automation, and many more. The vast number of applications are there from the field of CPS. And as I said you that why we have to do research in CPS, why research in CPS is important for us. So this is the main theme of our today's session. So I would like to cover some of the emerging research trends in CPS. So why we have to focus on this area. The foremost area where the CPS needs from us to contribute our research. The first one is security and privacy. As you know very much, even though we build, we implement, and we introduce the latest technologies, but always the latest technologies will suffer with security and privacy issues. So along with all the latest domains, the CPS is also under this threat, the security and privacy, where more number of cyber attacks and data breaches are targeting the CPS systems. And this is the foremost area the researchers can focus to implement various security and privacy mechanisms to prevent the cyber attacks and data breaches. The second foremost thing where we can focus as a researcher, that is edge and fog computing. So integration of the cyber physical systems with edge as well as fog computing. So what kind of results will come, that we need to see somewhat deep, that we will discuss. And as Professor Viswanathan sir already highlighted about the need of artificial intelligence and machine learning domain with integration of cyber physical systems, that will help us to enhance the adaptive controls and also predictive maintenance of the industrial machinery. And also we can detect the anomalies in various domains, especially in industrial automation. Anomaly detection is much more important. So these three are considered as the the most prominent research trends in CPS. And coming to the second three, where after the first three research domains, the next three research domains are also growing up in the last few years. That is interoperability and standards of CPS systems. You know very well, the CPS systems are heterogeneous systems. So the biggest challenge here for us is the integration of the heterogeneous nodes, heterogeneous devices in CPS, or one CPS system to other. Sometimes CPS system with cloud or fog, or as well as the other technologies. The integration is the biggest challenge to us. So researchers can also focus on the interoperability issues as well as the building up the various standards. Digital twin technology, the last few years, it is one of the highly prominent domain where the real-time virtual representations of the physical assets that will help us to better handling the situations of the physical devices. Fault tolerance can be enabled, and better than the simulations, the digital twin technologies will help us to understand the physical systems in very well. And the last, you know very well, the energy efficient CPS designs are the main goal of any CPS researcher. Any design we would like to do in cyber physical systems, that must be energy efficient, that we today calling as green computing. So all these 6 domains, like security and privacy, edge and fog computing, integration to CPS, AI and ML usage in CPS systems, then interoperability and standards, digital twin technologies, and energy efficient CPS designs are the 6 the most prominent research trends in cyber physical systems today. So I would like to focus a little bit deep into these 6 the most prominent research domains, so that in future you can choose any one or multiple domains from these, and you can continue your research field. So first prominent thing is that the security and privacy in cyber physical systems. I hope in one of the session yesterday or day before yesterday, I hope one of the professor has already covered about various security issues and also the privacy, the preservation techniques in CPS. If you see on the screen, it is very clearly you are observing that these are the key trends in the security and privacy of CPS systems. The modern CPS systems, such as smart grids and industrial systems, are highly connected and highly vulnerable also. Why I'm telling they are highly vulnerable? Because there are so many types of the attacks, like ransomwares, DOS and DDoS, man-in-middle attacks are targeting the CPS systems, and there is a lot of data breach also happening in these devices. So attackers are targeting the sensors, actuators, networking protocols, and the control systems or physical systems in the CPS, and disturbing the CPS operations, and also stealing the most sensitive and valuable data. I would like to bring your attention to one of the website here. This is the cvedetails.com, where we can see various types of the vulnerabilities. This is common vulnerability enumeration details. If you are seeing on the screen, I hope my screen is visible to you, everyone. Anybody, can you confirm me? Is my screen visible to you?
Yes, sir, it's visible.
Yes. So if you see on the screen, this is the cvsdetails.com, common vulnerability enumeration, the website. You can clearly observe on the screen here, there are various types of the vulnerabilities are growing up in the field of the security and privacy of CPS systems. If you see on the screen, here this website has published from the year 2015 to 2025, the latest, the vulnerabilities by the categories or by the types. For example, buffer overflow and memory corruption. The SQL injection is another kind of vulnerability. Cross-scripting attacks, directory traversals, file inclusions, cross-scripting attacks, and open redirecting, SSRF, input validations. If you see, all these are the growing and most the dangerous vulnerabilities which are targeting the Internet of Things and cyber physical system devices and also the technologies. And if you see the impact of these vulnerabilities, the impact is also calculated. The code execution attacks on screen, you are clearly observing that it is the major impact it is resulting along with denial of service attacks, information leak, privilege escalations, and bypassing techniques. So all these are the vulnerabilities if you see from the year 2015 to the last year 2024, the vulnerabilities have grown up. Like 6,494 vulnerabilities have recorded in this website in the year 2015. But when you come to the 2024, almost 40,030 vulnerabilities have been grown up in the last 10 or last 9 to 10 years. So if you see the vulnerabilities by the type, this graph is showing you the majorly memory corruption, SQL injections, cross-site scripting attacks, buffer overflow. So these are the major vulnerabilities are targeting the cyber physical systems. And here you can also observe very carefully, for example, Arduino based vulnerabilities. If you want to, for example, ESP32, okay, I would like to target here. So now you can see that ESP32 modules, which are a familiar Arduino board module used for IoT. Even the ESP32 firmware vulnerabilities were also recorded here. So latest 2025, the March 6th, one vulnerability was detected on ESP32 firmware, which we popularly uses in cyber physical systems design and implementation. So like the way any kind of device like Arduino boards or Raspberry Pi boards or any kind of hardware or technologies, like example, like a famous OS, okay, if you see our Microsoft, we see here. So in this, we can clearly see that even Microsoft is also facing many vulnerabilities. Now we are observing on screen. So last 2015 to the latest 25. So these are the various attacks targeted even the Microsoft devices or the hardware, software also. So like the way if you see any kind of technology, even the iOS, okay, I can see, I want to show you here. So now we can see like a kind of Cisco iOS. So Cisco devices, these are the Cisco and iOS operating system version you are seeing on screen. So these are the different versions and all these are the different vulnerabilities and their version details are also available on the screen. So what I would like to convey to you, now you can see how many, almost 7,000 plus versions the Cisco's iOS software as well as the hardware devices were targeted, and 618 vulnerabilities have been detected here. So from this website, it is a very clear evident to all of us that the vulnerabilities are really growing up much more in the field of cyber physical systems. So it is very much needed from you, all of you, that to focus on detection of the vulnerabilities and threats and analyzing them properly and finding the mitigative solutions to prevent, to secure the cyber physical systems. So any kind of technology, if you go to cpsdetails.com, and there you will find the so many number of the vulnerabilities from last few years which were detected what are their versions, what are their CVSS scores, and how they were mitigated. And some vulnerabilities are still not mitigated also. So this kind of work where as a researcher, you can focus on that. So as a researcher, what you can do in this domain, I would like to give some of the thoughts from my side, but they are not limited or restricted to you. You can explore the more the research solutions in this domain. But these are some of the areas where the earlier researchers have focused much. That is the lightweight cryptography models and secured communication protocols, development and design for cyber physical systems. Because already you know very well, CPS devices are very resource constrained devices. So any cryptographic models or secured communication protocols we are designing for CPS devices must be under the very less resource consumption. And intrusion detection systems, of course, my research scholars are focusing on this particular part in VIT Vellore. So we are developing a artificial intelligence based intrusion detection system in our laboratories to detect the various intrusions targeting cyber physical systems. So, end-to-end encryption and trusted execution environments where it has to design to enable the secure data transmissions. Of course, the privacy preservation algorithms are much more demand in CPS so that you can focus on different kinds of privacy techniques, key generation algorithms, and federated learning integration in privacy preservation algorithms. Really, it is a booming up topic now. So you can find so many articles, especially in this domain, the usage of the federated learning in privacy preservation of cyber physical systems. And some of the challenges as a researcher, you need to consider these challenges while you are doing research in security and privacy in CPS. For example, the balancing the security overheads. As I told you, the CPS devices are very resource constrained in terms of lesser memory and computational power. So while you are designing any kind of security mechanisms, that should not result the security overheads on the devices. And also it has to boost up the real-time performance. And the resource constraint, this is one of the biggest thing you need to consider. And protecting the legacy infrastructure with weak and no security provisions. Of course, while we are designing any new technologies, it is our responsibility to protect our legacy infrastructure. And any new technology we are building up, that must be adaptable to the legacy infrastructures. And on screen, I'm showing you some of the references also. You can see later on them. We will share the material with you so that in your free time, you can also focus on the web links, okay, which we are showing you on the screen. For example, if you go to IEEE access on here, the link, okay, we have given to you. And I will open simultaneously the next one also so that we can see the both of them at clearly. Now, this is the one of the familiar article published on the same domain what I discussed now. So, yeah, just sorry, I think. Yeah, I will move on to that, and maybe I'll show in through some other link here. And come to the second part of the research domain here, the edge and the fog computing. So this is another research domain where you can focus very well on that, like integration of the cyber physical systems with the edge computing and as well as the fog computing. So you know very well the traditional cloud-centric architectures. We have designed, developed the cloud-centric architecture very well in nowadays. But when we come to the integration of the CPS with the cloud, we are facing the unacceptability of the latency. So latency is the biggest the trouble to the researchers or also the developers of CPS, the backend of the cloud infrastructures. Especially the latency is absolutely not at all acceptable in the CPS applications like autonomous vehicles and also the medical applications. So we need to explore some more the new computing technologies where the latency we can minimize to very minimal, or if possible, it is to the zero level. So edge and fog computing architectures here we help us to push the computational storage as well as intelligence very close to the physical devices. So CPS devices can easily integrate with edge and fog. So the real-time analytics at edge and fog layers can support the low latency, even ultra low latency. And we have a very good hierarchical architectures like backend is a cloud, and the middle layer is a fog, and the front layer is the edge. And edge always interact with CPS systems. So cloud, fog, edge with CPS, that really help us for load balancing as well as the scalability. Even many more security challenges like privacy preservation challenges, these things we can overcome, and also by protecting sensitive data at distributed edge nodes. So edge computing and fog computing with CPS is another new area. As a researcher, you can focus much, and a fruitful outcome you will get from these domains. And the challenges, of course, in this domain, when you are choosing this domain, the most important thing is the managing the mobility, because the edge devices as well as the fog computing devices are much more mobile. So mobility management is one of the challenging thing where you can focus much to design a mobility managing algorithms, and how to handle the heterogeneous devices. So what is heterogeneous? Heterogeneous are different configuration devices. Edge devices are having different configuration. Again, fog devices are different, as well as the CPS devices are in different configurations. So what we are doing is that here we are merging three different configurable devices into one network. So this is the biggest challenge for us. So as a researcher, how do you handle them and make them to connect, establish the network connectivity, and make the data flow very easily? So this is one of the good area for you. You can focus on that. And also the orchestration of distributing resources more efficiently. So like a kind of memory management and computational power, minimizing the latency issues, and better network capabilities, handling the networking protocols. So all these things like a very challenging things to us as a researcher. So you can focus on here. So there are very good articles have been published on this domain. So you can also see these web links. Just give me a second. Okay, I think here it is opening now. And this is one more. Yeah, this is IEEE Internet of Things General. If you see on the screen. Yeah, this is one of the very familiar the general IEEE Internet of Things General. So it is expecting a papers from this kind of the research domains. So please look on to this general, and there are very good papers are published, integrated sensing and communications, the recent advancements, state of art and future challenges in unmanned air vehicle SFAMs. So like that, very good. Even federated learning. This is a thing just now I was highlighted a few minutes before. The federated learning for medical applications, taxonomy, current trends, challenges, and future research. So these kind of articles and the publications in the journal can make understand more about the emerging trends in edge and fog along with the CPS. And when we come to the third most important point where our Professor Viswanathan sir was highlighted about this particular domain. So AI and machine learning, the role for cyber physical systems. There is no need to tell much about the need of AI or the need of machine learning in cyber physical systems. But we need to understand where we can use them or how to use them to continue my research areas. So CPS systems are really increasing and adopting AI and ML models. The purpose of this is so that CPS models can become data-driven, adaptive, as well as they can perform the autonomous operations. So predictive maintenance is one of the most the demanding thing from the industrial automation, where we have to predict earlier the need of the maintenance to the machineries and also the physical systems, whichever it is. So for that, the deep learning models can help to understand, to find, or to predict the maintenance of the physical systems, so that we can save from the failures of these physical devices, and we can increase the lifetime of the physical devices. So today we have n number of the physical devices in CPS, but we are not much focusing on the predictive maintenance so that we can enhance the lifetime of the physical devices. So Industrial 4.0, today Industrial 5.0, smart manufacturing units, aviation department, right? You are seeing in the news, right? Even recently also, one of the aircraft, right, it was got damaged, okay, during the flying time. And it resulted very great, right, impact, right, to all of us. So imagine that if our AI models, the deep learning models forecast before that aircraft needs the predictive maintenance, if we do that, then such kind of the accidents or panic situations will not rise up. So not only aviation department, even industrial accidents, we can avoid them. Tomorrow, the cyber physical systems will come into the various applications into the civil domains. A user can use the CPS devices everywhere, anywhere in the houses. So every physical device we are monitoring through CPS needs a proper maintenance. So for that, the deep learning models are the best domain where you can focus on. The reinforcement learning is another part of the AI field, so which can help us to make adaptive control of the complex dynamic systems, right? The self-driving cars, autonomous vehicles, they are much more demanding now. For example, drone applications today, the drones we are using in agriculture field and like a military field, and self-driving cars are much more demanding in upcoming days. Even for our country, self-driving cars are much more needed. So even in a congested traffics, in a very narrow roads, but the reinforcement learning models are, if we develop them for CPS systems very well, so that even our congested traffic and road conditions, the self-driving cars are possible to our country. And anomaly detection, so where the detection of the anomalies, especially security anomalies, are using AI models to detect the real-time threats, to recognize them, understanding their patterns, and making our system robust to prevent the upcoming threats. So using the existing threats, the AI models will get trained, like a machine learning and deep learning models will get trained and understand the patterns of the anomalies or intrusions which are breaching into our systems. So let the next level, our security mechanisms will get strengthened and detect the upcoming threats and block those threats. So such a way, as a researcher, you can also focus on anomaly detection models, strengthening the intrusion detection models using AI technologies or machine learning and deep learning models to detect the real-time threats, upcoming threats, understanding the pattern of the threats, and finally, how to mitigate those threats. And federated learning, already I had shown you just before one article. So training the federated learning models in a distributed CPS components where it is much more helpful to protect the data or enhance the data privacy levels. So this is one more the researching domain where the researchers are much more focusing from all over the world. And of course, there are some challenges you need to consider. Maybe these challenges will become a strength for you to address, to focus on the areas. Because in the lot of literature, when I've gone through, so these are some of the challenges have been highlighted. So these challenges, as a researcher, you can focus on that, like a limited data quality, where CPS devices produces very limited data quality. So how to take the low data as input to your model, and your model will generate the high quality data. So such kind of research you can focus on. Heterogeneity of the data. As I said in the previous slide, the devices in CPS are heterogeneous. So data produces from CPS environment is also heterogeneous. So all the data will come in a different formats. Even as I said, the researchers who are doing a PhD under me. So this is the biggest challenge thing to the researchers, that the CPS devices produces a vast amount of the data with and the much heterogeneous data. So now the biggest challenge is handling that heterogeneous data, processing that heterogeneous data, and understanding the features of the data, and using the data to train the AI model is not a simple thing, what I am saying easily as a wordly with you. So when you go actually deep into this domain, you will understand how big a challenging thing it is to the researchers. So if you take this kind of domains, maybe your research will have a great impact in the society. And real-time AI decisions on resource-constrained edge devices. So designing edge to the CPS devices, mainly modeling the AI models to the resource-constrained devices. And security, of course, secured AI models, so that the machine learning related attacks which are targeting CPS devices, so that we can prevent them. So this is one more good area as we can focus on security enhancement to prevent the adversarial ML attacks, and to mitigate the compromise of the CPS devices. So these are some of the articles have been published. We can see them later on. And another booming up area in the same domain, that is edge artificial intelligence. As we know very well today, in these days, everyone talking about artificial intelligence. But as a computer science people, we have to think a little bit advanced and find the new technologies to do our research. So the latest technology from the artificial intelligence is edge artificial intelligence, where the AI will be combined with the edge computing, and the distributed learning algorithms will help the edge devices to understand the various surrounding parameters, so that the AI models can completely become decentralized. So as CPS devices are decentralized in the nature, so edge artificial intelligence and distributed learning models are significantly help the field of the cyber physical systems. As I again mentioned that the federated learning models are the best suitable for the decentralized edge devices, mainly for smartphone and IoT sensors. So you can think in this kind of the research domain, really it will help you if you are starting your research or planning to register your PhD in any good university, and you are in a phase of searching a good problem statements. So I can refer this, the edge AI, the distributed learning models for cyber physical systems or Internet of Things. So this is one of the best area for you. And another thing, if you are interested in a hardware design and development, so edge AI hardware is also another the most important domain from the industries. So we have a close interaction with the industries, So we received so many requests from the industries to make our students to work on various projects to design and development of edge AI hardware. Of course, we are pushing up our undergraduate and graduate students to focus on to building the edge AI softwares, hardwares, middleware, or firmware. So this kind of projects, the industry is much demanding now, right? I would like to show one article published on this, the edge AI hardware. This is a website called adventech.com. This is the site where we can see different type of the edge AI computers. So today industry demands these things. You can see here the features and benefits of edge AI. So GPU empowered IPC for versatile industrial applications. And on screen you are seeing different wide variety of the hardware, especially the GPUs like RTX 4000 devices you are seeing for factory automation, and RTX 6000 A series for industrial equipment manufacturing, then OCR applications and AI applications here. So equipment you are seeing on screen, right, with the AI and AOI. And OCR inspections like utilized optical character recognition technologies for real-time text and code verification in the factories, and streaming quality control, minimizing the misleading and incorrect assemblies. So you can see that Intel, NVIDIA, as well as their reliable and hybrid performance systems. So this is the hardware configurations like AI IPC sections and different types of the devices you are seeing on the screen, and different NVIDIA GPU cards you are observing on the screen. You can also download this brochure and get some more information about them. And these are the different products on screen. So like you can see the latest products from Edge AI, like IPC 320, its configuration on the screen, MIC, and if you go on, very tiny and very small devices also we can see here, so that you can understand that how much industry is demanding today for edge AI softwares, hardware, design and development, as well as the firmware and middlewares. So various GPU applications, one article is published here, AI controllers and AI to the edge, advancing edge AI systems application cases. This is one of the very wonderful site where you can explore, you can see here, edge AI cameras. So today we are seeing a normal cameras like which we are using, but tomorrow these cameras are changing its shape to edge AI cameras. Now we can see on screen, these are the a normal camera. It will do as it is, but at the same time, enabled with artificial intelligence models, and also it is the edge device. So edge artificial intelligence camera is the future direction where industry is focusing, and some of the products already developed and you are seeing on the screen. And like edge AI servers and GPUs. So much more very good information was published in this article, in this website. You can see them, and you will get an idea. So where you can focus on, these are the edge AI servers, right? So you can see on the screen. So different, the artificial intelligence is changing its shape and integrating with cyber physical systems and edge computing, and going into another kind of the shape here. But remember that when we are designing any kind of the edge AI with the computing, edge computing technologies, energy efficiency is the most important thing where we have to focus on. So energy efficient is the most important paramount concern in CPS devices. So any kind of technology we are introducing in terms of it is a hardware or software or firmware or middleware or anything, so that must be energy efficient That is the most important goal as a researcher you have to focus on. The third important thing, as I going into the research domain where you can focus on the interoperability and standards in CPS systems. Yeah, this is the modern CPS systems today are diverse systems. They are from different vendors. That means sensors from different vendors, controllers and networking systems from different vendors, and all we are integrating them. So different data formats, different communication protocols, and finally we are using them for different applications. So all these things we are grouping them and making them as a single network. So now definitely interoperability will play a key role in cyber physical systems. So as multi-domain systems, and we are deploying them in a large scale, right? They are not a simple, a small in number. We are not using them in a small in number. We are using them in a large in number. So the scalability is there. So scalability with interoperability and following the well-defined standards of the CPS systems, that is a very challenging thing to the researchers. For example, development and adoption of the open standardized communication protocols. These are some of the protocols like OPC UA, DDS, MQTT, COAP. These are well-known protocols to us, but to enhance the interoperability, we need the next versions and next level of the protocols, communication protocols. So as a researcher, this is one more good area for you to focus on the development of the communication protocols for CPS and IoT systems. And plug and play capability, like the designing of the middleware solutions, so that heterogeneous components no need to suffer much for the installations. So plug and play mechanisms, if you design such a middleware solutions, it is one of the wonderful area in CPS. Then designing different data models, data analytics models. You know, the data science is booming up today. The reason behind is that the CPS systems. So as CPS is growing up, the Internet of Technologies are growing up. So the data production from various CPS devices are larger, so that the data models, data analytical models, and data handling models or preservation models, processing models are growing up. So another thing is security framework and trustworthy. No need to tell. I have discussed it many times in the previous slides. Of course, as a researcher, these are some of the challenges to us, like heterogeneity and proprietary protocols. Most of the protocols are like commercial protocols or proprietary based. So like designing the open source protocols, as a researcher, you can focus on. And legacy systems, how to handle them, how to integrate no new protocols into the legacy systems, and handling the vendor lock-in tools. This is also another thing you need to focus on that. So these are some of the good references I have given for your understanding on the interoperability. And this is NIST actually published a very good report on cyber physical systems. If you see on the screen, this is a different frameworks for handling the interoperabilities issues. The NIST has published in the official site. So you can refer this web link later on, so that you will find what are the available frameworks as on today. So volume 1, different set of volumes were there. And this is a download link to the paper. And NIST publication series, special publications link is available, so that you can refer them, understand what are the existing frameworks for cyber physical systems, so that it will help you to design the new kind of any interoperability technologies, or to design any kind of the standards. Even IEEE also published various CPS standards here. So no, as a researcher, it is another important thing for you to understand and to know what are the available standards for us. So if you see on screen, the IEEE has published a very one good article on this. Various types of the standards available for CPS systems. For example, a review technology, standards and patent portfolios for enabling cyber physical systems in advanced manufacturing. This is one of the article published. So like that, a very good number of articles are available. Refer them, understand the existing standards in CPS. Whether you want to introduce any new standard into the CPS systems, it is well and good. Or updating the existing standards, this is also one more good area for you. And one more research domain, I would like to focus on that, the digital twin technologies. This is one of the very wonderful technology in cyber physical systems, which is growing up in the last few years. And a lot of attention is paying from the industry side. Digital twins are the virtual real-time models of the physical assets or systems or processes. So creating the digital twin technology, that means that creation of the virtual, like a virtual system for a physical system, or virtual asset for a physical asset, right? And real-time modeling is possible to us so that we can understand the behavior of the system very well before its deployment, and we can test the system using digital twin technology so that we can understand what kind of the changes the system need before it deploy in actual real-time environment. So the digital twin technology will help us to do the simulation, monitoring the physical assets through virtual mode. We can diagnose this also. Any errors are there. So before deploying that system, we can find those errors and diagnose them. Then later we can go for the actual deployment. And predictive control is also possible very well with digital twin technologies. And these are some of the research areas like implementing the scalable digital twin systems for manufacturing industry, energy, healthcare, and infrastructure. And again, integration of the AI models in the digital twin technology for predictive analytics. So defining various scenarios, process optimization. This is one more a very wonderful domain. Our professors from electronics and electrical domain, they are much more focusing now on AI enhanced digital twin technologies for predictive analytics and directional data flow for real-time synchronization between physical and real environments, integration of the IoT, cloud, big data with a digital twin of CPS systems. What a wonderful areas really these are. So as a researcher, any one or any multiple domains you can choose and work on, really it benefit not only you, it also benefit the industry and our society and our country very well. And if you see some of the challenges, even though these technologies we are proposing, but the high fidelity is the most targeted thing for us. For example, high accuracy, high precision from digital twin technologies when we integrate with AI and cloud and IoT. So this is a very challenging thing for us. And real-time data integration, cyber security for digital twin platforms, and scalability. As I said, our CPS systems are much more scalable. So scalability for single asset or multi-asset twin technologies is where the challenging thing as a researcher can focus on that. On this, the IBM has published a very wonderful article on these challenges. So refer these websites, what I have given on this, so that you will get some idea. So you can proceed into this domain. And I also said many times, whatever technology we build up and we introduce in cyber physical systems, any design you can do, but that design must be energy efficient. It must be comes under the green computing. So unless until if your design is not energy efficient, then your design is not efficient. So energy efficient CPS designs are also growing up the research domains in this field. So research trends, just I would like to show you on the screen. like a green computing techniques for embedded and edge devices, autonomous energy management. This is the most important thing. Instead of somebody monitors the CPS devices for energy management, if a CPS device by itself do the energy management in an autonomous way, so that lot of energy, okay, we can save, then this CPS and IoT, such kind of technologies will really help the society. So as of now, we are designing various energy efficient mechanisms, but ultimately these energy efficient mechanisms are not autonomous. So somebody has to monitor, or some system has to monitor to achieve the energy efficiency. But understand that as a researcher, if you think and plan for self or autonomous energy efficient technologies for CPS systems, along with artificial intelligence models, really it would be a wonderful domain in this area. And energy efficient protocols design and development for low power wireless communications, especially for sensors and actuators, is also one of the good area. Of course, I can happily say that my research domain during my PhD is this part, designing and development of the protocols and algorithms for low power communication in sensors and actuators, where in the 2011 I was started my research domain, chosen this area, and I have done my PhD in this domain only. So point is that some years back we predicted and we have done. So as a young researcher, you think somewhat beyond what we are saying and publishing here, so that you can find a better problem solutions and do them. So balancing the energy saving for real-time operations and integration of the renewable energy sources. So this is the one more important area where we can focus. Instead of traditional energy sources, why can't we think about renewable energy sources? So we have a plenty of renewable energy sources we have. As of now, right, we are only focusing on the traditional energy sources, and these traditional energy sources are restraining us, in many ways. So if you think for renewable energy sources, for example, a sensor with a renewable energy source, a actuator, a edge device with a renewable energy source, I think the device become autonomous and will not depend upon anyone to get chargeable, and the device will exist for longer duration. You know, the cyber physical systems, especially Internet of Things, when we deploy for the military applications, the biggest challenge for us is these devices are low energy powered, and the lifetime of these devices is very limited. So when we deploy in a very sensitive zones for a military applications, these devices are going to dead very quickly, and the entire network topology or communication is getting disturbed. So if we think for renewable energy sources for the CPS systems, especially for IoT or sensor networks, so the device can exist for longer duration, network exists for longer duration, so that data transmission can become more efficient to us. So on this only, this particular articles in Science Direct, okay, the energy efficient cyber physical systems, energy efficient approaches for cyber physical systems in Springer. These two good articles have been published. Please refer them later on. And finally, the 5G technology, which is upcoming for us very soon in our country. So integration of the 5G technology with CPS can also give a remarkable change and change the CPS into another shape. So these are the latest technologies in 5G. So if you are interested in 5G technologies, you can also think for integration of the 5G with CPS, so that these are some of the areas where CPS applications needs, like ultra reliable, low latency communication, massive machine type communication technologies, enhanced mobile broadband systems called EMBB, network slicing, so where you can focus on much, and multi-access edge computing, MEC, with CPS systems. So this is one of the prominent domain. Again, for the researchers, integration of the fog, cloud, as well as the MEC, then along with the CPS. So I have given a comparative table here, cloud, fog, and edge. You can see that edge is absolutely outperforming with the CPS systems, so that low latency as well as light computational processing. So these capabilities will help the edge AI in CPS would be the leading research domain. And finally, when I'm coming to the conclusion part, so I would like to highlight some of the tools for CPS research. Maybe these are not limited, because you know very well tools will keep on change, and the tools will keep on upgrade, and a tool which is exist today will not exist in tomorrow, or will change its shape into something. So as on today, if I talk, these are some of the good tools to do your CPS research. Of course, the most of the researchers are using Simulink in the MATLAB, which is one of the very good tool. So for comprehensive modeling and simulations of CPS, a very rich libraries are available. So about MATLAB, I hope there is no need to tell much about to you, because all you are the faculty members, you know very well about MATLAB. I hope you have a very good experience with the MATLAB. And NS3 is another familiar tool. Of course, this is also some of the researchers know about NS3 tool. This is one of the very good and very popular tool, mainly for design and development of communication protocols and the simulations. So NS3 is a very popular. Earlier we called NS2, but now it is NS3, a discrete event network simulator for Internet of Things, and targeted primarily for research and educational use. It is an open source tool, so that you can, NS3 is a completely free tool, open source. And as a researcher, you can download it. Very good documentation support is available. Very good publications have made using NS3. So I have used it when it was NS2. Later, right, it changed to NS3. And very good amount of research publications are happening through this network simulator tool. And after NS3, one more a very familiar tool. This is a little bit older tool, but it will have its own importance. Like Omnet PP, this tool I have used during my research time. So till this tool is existed, and really a very good number of projects are happening using this Omnet++. Extensible, modular, component-based C++ simulation, very lightweight tool, C++-based development environment, so that you can easily handle it. And a very good number of projects like INET framework, and these are the different integrated simulation tools are there, existed above Omnet++. So latest version of Omnet is 6.1.0 is available, and one article was also published on this spam attack detection on Omnet++. So different versions are available. Please refer, use it as a researcher. You need to use and test it. After that, you came to know whether this tool will support to your requirement or not. So just by reading theory or listening somebody who says about strengths and limitations, it is not a right way of judging the tool whether it fit to me or not. So the right way is better you download it and use it and get experience of this tool, so that you can understand very clearly whether this tool really help you for your research or not. And Professor Viswanathan sir also highlighted about this Open Modelica tool. This is a one more exclusive tool developed for cyber physical systems, so that the web link was given on the screen. And now I am opening this openmodelica.org. This is a exclusive open source tool for cyber physical systems. On screen you are seeing. This is for industrial and academic usage. It is available. So most of CPS researchers are using this open Modelica tool. So downloading, yes, you have a facility of Windows, Linux, Mac users, and Docker version is also available. You can run it on the virtual machine. So it can fit to all the environments, and a very good user documentation. And there are some more tools are also built up on Open Modelica, so that you can find those tools here. And this is a developer page, and very good research is happening using Open Modelica, like some of the conference papers, journals, even PhD scholars are also, they published their theses using this Open Modelica, master theses, books. So this is one of the well-known tool for cyber physical systems researchers. So you can see various versions of the tool, and it is one of the better recommended tool to all of us. And one more tool, it is a cyber physical system simulator. This is actually built up upon OMNet++. As I already said about OMNet++, extensible modular C++ based tool it is. So based on this, this tool was developed called COSIM. What is COSIM? Cyber Physical System CPS Simulator Framework. So COSIM Simulator Framework is an open source again, high performance simulator. So this simulator was actually built up upon the OMNet++. So it has already published in the OMNet++ website itself, so that the website is there and GitHub is also there. You can check them, right? So then after that, one more co-simulation platform you can see later on. And finally, if you see on the screen, these are the major tools. I have just given a comparative study. As a researcher, you can do a comparison on these are the different tools and domains like a Simulink, OMNet++, Open Modelica, Mosaic, and CS, CPS, SIM, and their strengths and limitations, and their websites also have given on the screen. So as a researcher, okay, you can first try every tool, right? Because during my PhD also I suffered. Somebody says, right, this tool will be the best for you. Another one says this will be the best for you. But ultimately, the final judge is ourselves. So we have to test and finalize it, which is good for us. So unless until without using the tool, we cannot rightly judge whether that particular tool can help my research or not. So my suggestion, at least find the best tools for your research and download them, install and use, so that you get a better clarity whether the tool can fit your requirement or not. Of course, which is selecting the right tool. I already said about this. Nobody can tell to select which is the right tool for your research. You are the right person to select the right tool for your research. But when you are selecting a right tool, you can also consider the licensing, its cost also, whether you are looking for open source or commercial tool, or you want better community support and documentation, and what kind of research, okay, whether the tool can help you to perform your do your research or not. So that are like a physical and cyber focus, and it will fit to your models and requirements. So all these some parameters you can verify and finalize the tool, and the reputation of the tool also, right? Whether the tool is the latest one or not, and how many publications have done using the tool. That is a much more important. That's why Open Modelica, when I shown that website, you have seen that they were very clearly published how many conferences and journal papers have been published using Open Modelica, PhD theses, MTech theses. So that this is a clear evidence that many researchers have already used, and many universities have already considered that particular tool. So selection a tool you need to consider all these things and do the selection and continue your research. If you choose the outdated tool, a tool which is a low prominent, maybe the tool is more familiar to you, but if the tool is not prominent and not considered by academic society, then later at the end of the submission of your thesis or your paper, the results you have produced using the tool are questionable. So you need to think in that direction also. Then some of the emerging CPS research, I already told. If you want to extend your research, trustworthy AI, heterogeneous systems, real-time analytics, robust integration of digital twin AI, and ensuring the resilience CPS systems against the cyber physical attacks. And CPS research, as a conclusion, I can say that it is a fast evolving multidisciplinary domain. So if you want to choose this domain, it is one of the best domain, fast evolving, and it is a multidisciplinary. Very good number of tools are available for design, simulation, and integration. And very leading journals are ready to take up the papers for CPS with AI as well as Edge and Fog. So IEEE, Springer, Elsevier, so many very good number of journals and conferences they are available. Now we can see some of the useful links to you. All these links are very useful. For example, if you are a serious learner of CPS, cyber physical systems, there is a virtual organization is there for you. So as a researcher, as a student, even whether you are undergraduate or graduate or a PhD scholar, whatever it is, or a faculty, if you want to learn more about cyber physical systems, of course, whatever we told you, all these are very limited things. But to learn more things, there was one virtual organization is available, Cyber Physical Systems Virtual Organization. Here you can get login and get registered. And here you will find a very good number of tools. Even whatever tools we have shown you, maybe they are generalized tools, but these are more specific tools to CPS like ALC, Toolchain, Seam Design Studio, BIP, Hierarchical, right? And Grid, right? Deep Forge, Deep Design. So these are the very good number of tools. The latest tools are published in this organization. Research projects also available. So if you want to know what are the research projects are there, I hope on screen you are seeing CPS. Just I will read some of the titles so that you can get enlightened. CPS, Small Cyber Physical System Challenges in Man-Machine Interfaces. CPS, Small Community-Based Sense Response Theory and Applications. Collaborative research using CPS, right? And workshops are happening using CPS. Fundamental limitations in CPS. Robust CPS technologies. Sensors in CPS. So if you see on screen, there are so many, a good amount of projects are listed. So as a UG student from M.G.R University or from other university, if you want to do your projects at undergraduate or UG or even at PhD level, you want to continue research, these are the very good amount of projects were published in this virtual organization. Of course, IEEE Technical Society is available on this. ACM special interest groups are available, and Springer book series are published, and NFS CPS programs are available. This is also you can see. United States also focusing much on cyber physical systems from NFS.government, like a US government National Science Foundation. This is a website you can see the cyber physical systems. On screen you are seeing. Right, they have published a synopsis and a very good amount of information is available. You can see them, right? So this is a NFS cyber physical systems, right? You will get some more good information from here. Then finally, I'm coming to the conclusion to end up the today's presentation. So at last, okay, I would like to close my session to give you some of the meaningful insights into this, like 5 top research funding agencies, because faculty generally expect that what are the research agencies are there in India to get funding in CPS. So you are warm welcome to submit your research proposals right in these agencies. So in India, our government of India is contributing a very good amount and support giving to cyber physical systems. And these are the prominent research agencies like a DST, so CPS National Mission, Innovation Hub, DST taking up the proposals, SERB, MITI, and IANE. And this is one of the most important thing in India, ICPS, Technology Innovation Hub. So that I was highlighted because of that. You can see on the screen, ICPS comes under the Department of the Technology here. So this is the, you have to understand how much our government is focusing on the cyber physical systems. So if you see on the screen, this is ICPS, comes under the Department of Science and Technology, National Mission on interdisciplinary research in cyber physical systems. Okay, our Prime Minister Modi ji was well supporting to this organization, this hub. Especially this was formed very recently, and you can see on screen, this is exclusively for cyber physical systems. As on now, on screen, right, the technology development, 1700 plus technology products, 400 plus, right, the partnerships, entrepreneurship, and commercial products have been developed. Almost 1.8 lakh plus professionals are trained. So this is a keynote about okay, our Prime Minister sir. Here you can see on the screen vision and scope, and this is exclusively for cyber physical systems. So as you are a serious learner in this domain, you can also see call for proposals are available, and different courses are available here. So if you want to learn some more additional courses for CPS systems, now you can see workshop on power systems, transforming healthcare, AI-driven drug discovery. So these are the different courses are available. As a student, as a researcher, you can focus on them. So one more, these are the international agencies, not only in India, even in USA also. Top 5 cyber physical system research funding agencies in USA. You can see on the screen, DARPA, Horizon, DOE, and Department of Education, then NFS. So all these are various things. And international, not only India and US, even many countries like Europe, Germany, UK, Japan, and Canada. These are the popular agencies which are accepting research proposals from us. So as a faculty, if you want to submit the research proposals, please go through these websites so that you will get right. You can get the facility to submit your research proposals to here. And of course, okay, I'm coming to the last the slide here. And international research centers, right? These are some of the top research centers in the world. And a very happy thing and proudly to say that out of top 3 research centers, our research centers at Indian Institute of Science, IISc Bangalore, Robert Bosch Research Center for Cyber Physical Systems, India. This is the most reputed and well-known in international research centers happening in cyber physical systems. So with this, okay, I will end up my session today. So this is a very reputed and every one of us to feel proud about that such a wonderful research center is there at IISc Bangalore, which is very close to us. So any chance if you have to visit IISc Bangalore, So better visit this research center where the cyber physical systems and a lot of research is happening to build up the mobile robot. And these are the team members are there, and a legged robot, right? I hope this kind of videos you have seen in YouTube, right? All are from this ISC Bangalore's cyber physical systems laboratory only. Our late President Abdul Kalam sir already, okay, he was inaugurated, and this is a very prestigious thing to us. And you can see this one, okay, very good PhD students, some good amount of information, okay, you will get from here. And research centers, clusters, lab centers. These are the various labs under this Center for Networked Intelligence, Focus Lab, Vista Lab, right? IASC, Nokia COE for networked robotics, and research facilities you can see. And you can also see on the screen various publications from the year 2019 to the last 24. A very good number of publications have happened from the research of this research lab. So we have to feel very proud, and we have a good facility. Of course, the remaining two, like Sweden and Germany, okay, maybe we don't get a chance to visit them, but one of the very good laboratory, it is very near to us, so that as a student or as a researcher, try to get a chance to visit this laboratory, so that you will get much more exposure from this. And as I said, CPS virtual organization, please join and be in the community of CPS and NFS industry. University Cooperative, this is a US-based community. So you can also join in them, so that it will be helpful to you to get the latest updates in CPS. So with this, okay, I would like to thank you everyone for giving this opportunity to learn and share some of the most valuable things of the cyber physical systems. Okay, thank you very much. And if anything you want to ask me, please feel free to okay, raise up your, okay, take up your mic and speak to me. Thank you.
Thank you so much, Dr. Anil Kumar sir, for such an informative and thoughtful session. Your presentation provided clarity on research trends for CPS. We now open the floor for participant queries. You may post your questions in the chat box. How are AI and machine learning being integrated into CPS for predictive control and anomaly detection?
Yes. So this is a very good question. Really, as I said in my presentation, it was really a very well-known and prominent topic. So integration of the usage of the deep learning models in edge AI and CPS systems can help you to detect the various anomalies, mainly the threats, so that the CPS systems are targeted by attackers with different attacking patterns, like a different attacks, like DOS have some kind of pattern. DDoS is also another kind of pattern. So AI models, especially the deep learning models or federated learning models, can help to understand the attacking pattern. So we train them and we test the models. Then after that, we deploy those models in the edge devices, where these models can detect the upcoming threats. Already, these models are well trained with the patterns of those threats, so that the incoming or upcoming threats can be detected by AI models. That will really help the security systems and control systems.
Thank you, sir. Sir, one more question is there. Is there any collaborative research kind of activities available, sir?
Okay. Activity with us or with any other agencies? What is yeah, from us, anything like already HOD madam and the responsible team members are here. Any kind of support you want, yes, we will help you. Already the most of information about funding sources, agencies, research laboratories, we have already published. It is there in our presentation. So still anything you want, feel free to communicate to us. Our details are with our organizers so that we can help you, right? To continue your research, especially for funding sources, yes, we will help you. We guide you so that you can move forward to make your proposal and submit your proposal to the funding agencies, and you can proceed. So in that any direction you want from us, absolutely, we are ready to help you.
So one participant is asking your mail ID to contact, sir.
Yeah. You can provide it, madam. I think as it is a public domain, so I'm not giving to that. You can share to him privately.
Okay, sir. Is there any other questions? Okay, no more questions. Shall we close the session? As we conclude today's session, I now invite Mrs. Tamilchelvi, Additional HOD, Department HOD, to deliver the vote of thanks.
Thank you, ma'am. Good morning, all. I take immense pleasure in delivering the vote of thanks for the last day of our 5 days faculty development program on cyber physical system. Firstly, I would like to express my gratitude to our speaker, Dr. Kakelli Anil Kumar, for his insightful and engaging session on research trends, tools, and for CPS. Thank you, sir, for your valuable time and contribution. We are also deeply grateful for our President, Engineer ACS Arun Kumar, sir, for his continuous support and visionary leadership, which has been a constant source of encouragement for our academic endeavors. Our sincere thanks to our Vice Chancellor, Dr. S. Geeta Lakshmi, Registrar Dr. C.V. Palnivelu, Additional Registrar Dr. V. Cyril Raj, Advisor Dr. Mehta, Rector Dr. D. Viswanathan, and Dean Engineering and Technology Dr. Etiraj, for their unwavering support and guidance in organizing this FDP. A special note of thanks to our head of the department, Dr. N. Kanya, for her dynamic leadership and encouragement, and to all our dedicated colleagues whose teamwork and planning have ensured the smooth execution of the event. Finally, I extend my heartfelt thanks to all the participants. Your presence has made this event a truly interactive and enriching experience. We look forward you to join in the upcoming events in the future. Thank you so much. Have a great day.
Thank you.
Thank you, sir.
Yeah, thank you, madam. Can I leave, madam?
Yes, sir. Thank you, sir.
Yeah, thank you.
Yeah.